Let's take a look at example 3.12. A rookie quarterback throws a football with an initial upward vertical component of 12 meters per second and a horizontal velocity component of 20 meters per second. Ignore air resistance. Part A asks us how much time is required for the ball to reach the maximum height of the trajectory and how high is this point? Okay, so they're going to fire this pass and it's going to go like this. And we want to know what is that maximum height reached here above the initial point. Now, the interesting thing about max height is typically you won't need to use the x direction unless they give you something about the x direction is needed for the y. But majority of the time, you'll only need the y direction. So we're going to say it starts at a height of 0. And we're trying to figure out what is the max height relative to that initial height. They tell me it's initially thrown at 12 meters per second. Now the fact that it is max height is telling me that this maximum height occurs when the vertical velocity component is 0. It switches from going up to coming back down, so that's our max height is telling us to put a 0 there. Gravity is the only thing acting on it, so negative 9.8 meters per second squared. They asked me to find two things here. They asked me to find the height and the time. So let's find the time first since they asked for that one first. So for part A, we're going to pick an equation that doesn't have y in it. So that would be equation number 1. So we have Vy equals V naught y plus Ay t. Go ahead, solve that for t. And so we get a time of our negative 12 divided by negative 9.8. And that time comes out to be 1.22 seconds. Now, to find the maximum height, you can do a situation where you pick an equation that doesn't have time, but now since we know time, we can just go ahead and use equation 2. So y equals y naught plus v naught yt plus 1/2 ayt squared. Plug in those values. So we had 0 there, so we have 12 times 1.22 plus 1/2 times negative 9.8 times 1.22 squared. Plugging that in, we find the maximum height is 7.35 meters. Now, usually when we do two-dimensional motion problems, we need both the x and the y parts. But in this case, when we're doing a max height, you can typically get away with just the y. All right, for part C and D, how much time after it's thrown is required for the football to return to its original level? And how does this compare with the time calculated in part A? And then how far has the football traveled horizontally during this time? Okay, so we're trying to find this time over here. And again, that time will be the same for these two events. How long does it take to go from here back to that same height, and how far is it between those 2 points? So those two times are going to be the same. That's our goal there. We'll fill in the rest of our information. So in the x direction, gravity doesn't act in the x direction, so we have a 0 acceleration there, meaning these two values will be the same, and that is that 20 meter per second number. I am trying to solve that x. The problem here is I don't know the time. So I got to find the time first. That's why they asked us to find time first. So they're saying, well, what if these two values are the same? Okay, so if these are the same, there's a little condition that happens. And it turns out that this is 12 meters per second. If those are the same, the final vertical velocity is the opposite of the initial vertical velocity. It loses 12 meters per second on the way up. That means it's going to gain an equal amount on the way back down because it's the same distance up and down, neglecting air resistance, of course. So I get a negative 12 here. Again, gravity is the only thing acting on it. So we have a negative 9.8 meters per second squared there. So at this point, if you kind of knew this little trick, you can use equation 1. If you didn't, you would have to go ahead and use equation number 2 and solve it that way. Okay, I'm going to use equation number 1. So I have Vy equals V naught y plus Ayt. So moving this over, so I end up with a negative 24 divided by negative 9.8 equals t. Now they're going to ask me to compare this time over here, which is 12 divided by 9.8, with this time over here that's 24 divided by 9.8. And we should see that this comes out to be what, 2.44, I would guess, unless there was some rounding issues, 4.5, okay. And so we see that this time is 2 times the time to max height. And that is only the case if these two are the same. If it starts and ends at the same height, so you get that symmetry. The time up and the time down will be the same. Okay. Lastly, we want to find this x. Whenever your acceleration is 0, you're always using equation number 2. So x equals x naught plus v naught xt plus 1/2 at squared all goes to 0. So all I need to do is take that time of that 2.45 and multiply it by 20. And I find out the distance traveled is going to be 48.98. So let's just call that 46 meters, or 49 meters. That seems pretty reasonable. 49 meters. There you go.